Hi, folks. Thank you for joining us at Coalesce. My name is Natty, and I am a Director of Solutions Architecture at DBT Labs. I'm going to be hosting this session today. The title of this session is Why Metrics Are Even More Valuable Than You Think They Are, and we'll be joined by Patrick Doherty, whose first name, fun fact, as it turns out, isn't actually Patrick. Patrick is the CTO and co-founder of Rasgo, and I've got a couple fun facts about Patrick for you. He and his co-founder raised their first round of funding 1 week before everything shut down at the beginning of the COVID pandemic, just in the nick of time. And he's also built out a data science model to predict which soda flavor customers would pick based on their location. So I'm hoping I'll see lots of folks weighing in on their favorite soda flavors in the chat so we can build a test set out of this talk for Patrick's model. On that note, all chat conversation is going to be taking place in the coalesce-y-metrics-r channel of DBT Slack. Coalesce Y Metrics R. If you are not part of the chat, you have time to join right now. Visit getdbt.com/community and search for Coalesce Y Metrics R when you enter the space. We encourage you to ask other attendees questions, make comments, or react at any point in the channel. And after the session, the speakers are going to be available in Slack to answer your questions. However, we encourage you to ask questions at any point during the session. Let's get started. Over to you, Patrick.
Thanks, Natty. Really appreciate the intro and excited to be joining everyone here today. I am in New Orleans, so this lovely wallpaper in my background is not my house, but it's the Hyatt. So for everyone that's here, excited to meet with you. And for everyone that's not, glad you can join us online. All right, let's jump in. We get to talk about metrics today. I'm excited to talk about metrics. I think it's going to be a theme this week with DBT, so we'll kind of get the ball rolling here. My personal belief is that metrics are even more valuable than you're going to hear that they are this week. So I wanted to share a few reasons for why I believe that. First, on background, like Natty said, I'm the co-founder and CTO of Rasgo. I'm personally based in North Carolina, but we have team members all over the country, which was part of the time that we were founded right before COVID, and definitely a nice part about how the world has changed recently. We started Rasgo 2 years ago to make enterprise data easier to use for everyone. Rasgo is an interactive data catalog. It integrates with DBT in your data warehouse, and it lets anyone run queries and interact with their data through a friendly UI. All right. So let's talk about the semantic layer or symmetric layer, as I like to call it. So what is the symmetric layer? So we're excited about the new DBT semantic layer because it helps with our mission of making it easy for anyone to get trusted insights from data in less than 5 minutes. So there's a few components that are coming out with the new DBT product releases that kind of started a year ago and have continued to bubble up through GitHub pull requests and comments in the DBT Slack channel. But the part that I'm going to focus on the most today is specifically the ability to define metrics in your DBT YAML files alongside your DBT models. The reason that I think that's really cool is because that YAML file definition for a metric allows the SQL generation to be both dynamic but deterministic, so that you can make sure once you've defined a metric one way in DBT, any tool that connects to the data warehouse and runs the DBT metric SQL query, it's going to return the same data, no matter if that's from a BI tool, from a Python SDK, from a UI or anything else. And that's super powerful if you've worked in data for a long time. I'm sure you've dealt with the pain point of having someone reach out to you and say, hey, I calculated this metric in Tableau. It doesn't match when I pull the data into Excel via the SQL query you gave me. So I'm really stuck. I don't know what to do. Can you please help me? That's an anti-pattern that we want to stop. And part of the solution to that, I believe, is the new semantic layer. But in addition to the concept of like standardizing the metric calculation, there's even additional opportunities once you have that metric definition documented that you can unlock about how your data consumers can interact with those metrics. So I want to talk about those three because I think you'll hear a lot about the consistent calculation, and that's super important. But let's talk about even some of the other stuff that takes it a step further. Okay, so first we've got to start with what is the DBT metric spec. So if you're thinking about that YAML file where you have your models and you go to add metrics to it, I want to just hit on briefly what are the actual components in the YAML file that you would be adding to define that metric. So this is an example metric. Obviously, it's a new customers metric, and there's a few things here that are collected in this metadata that you define that are important. So number one, we have just a metric name, which you can refer to via the DBT metric queries that you're going to run. But you also get a kind of friendly label where you can include, non-SQL safe characters, which is nice for like search and discovery if you surface your metrics somewhere. Metrics have to refer to a model. So that's where you're seeing this ref to a dim customers model. That's an actual model that exists in the DBT project already. And that kind of allows you to centralize both the SQL logic for how that table is getting created. And then obviously with the metric, the aggregation on top of that table that's building that metric column. That aggregation type is shown as the type of count. So in this case, this is a metric that aggregates by counting rows. The timestamp column is super important. So all of the metric talk that we go through, it's time series aggregation in every case. So you're always aggregating over some time period, or you can kind of override that by specifying all time, which would mean like for the entire history of that metric, let's compute it over the full time range. Next couple of items, so time grains. This is cool. So if you've ever had a weekly metric that you calculate, let's say weekly new users, that may be a metric that within the underlying SQL, you do a date chunk to a week, and you don't support that metric being aggregated up further than a week. This happens a lot if you're doing count distincts, and you're relying on that, the row count to be significant. You actually will need to specify explicitly what are the valid time grains to calculate the metric at. So that's what the list is there for time grains. And then finally, we have dimensions and the meta section. So dimensions are references to columns in the same model that exist as like categorical slicers. It's like how I like to think about them. So for new customers, you may want to slice your new customers by plan or country, as shown in the example here. That kind of indicates to the user, like, here's a valid group by clause to add to this metric query. And that's what the actual DBT metric query is going to do under the hood. Finally, we have kind of an unstructured field. So the meta tag, that allows us to put arbitrary key value pairs in there. You can see I'm kind of suggesting that you might want to put things in there around verification status or workflow. We'll get into that a little bit more in a bit. Okay, so out of this metric spec, I see three big opportunities to build on top of the underlying metric calculation and actually provide our data consumers with more functionality. So those three are going to be tied to the time grains and timestamp as opportunity one, the dimension drill downs, which are opportunity two, and then using that meta tag for more than just internal documentation. That'll be opportunity three. Okay, let's jump into opportunity one. Let's talk about automatic joins. So this was really cool. The first time I learned how this worked and kind of watched the GitHub PRs that were going out around the metric calculate function in the DBT metrics package, the fact that you can take two metrics and calculate both of them simultaneously, even if they don't exist in the same table, is really unique. It's something that when I've worked with BI tools in the past, always drove me nuts. So specifically, think about the scenario where maybe you have a revenue metric and a churn metric. And let's say those are defined from two different tables, because likely your sales data is probably in a different spot than maybe your account or your contract duration info. And so therefore, those metrics are going to be defined in two different places, but obviously they're related, and you often would want to look at them kind of overlaid with each other so you could get a sense of how they're related. It's really difficult to do that in a generic BI tool. So not to pick on like Tableau, but let's say we're working with Tableau. In order to take those two tables and first you'd have to aggregate them to the same time granularity in order to do a valid join. And then you would have to actually execute that join kind of in the Tableau side using the data blending in order to make a single data set that you could then visualize with like a line chart to trend revenue against churn. It's pretty unique that now with the metric definitions, that all goes away. So you can see this example query shown here on the right. This is a query that says to the dbt metrics package, let's calculate revenue and churn together in the same query, return them in the same data set, and even add a dimension group by in there. So why is this possible? So the reason that you can do this is because the logic baked into the metric calculation is going to create a date spine on our week column. So let's say if you had a column maybe called date or timestamp, and you had already decided that a week was a valid time grain for that date column, you can essentially create two queries and then join them together with an inner join because you're making that date spine first, and you're guaranteeing things like no row loss if you have null values for a certain week or no values in the data set. So that's kind of a unique part that's introduced by this semantic modeling layer. And I do think it's massively powerful, and we haven't even necessarily unlocked all of that yet. So that's one of the big opportunities that if you think about your data consumer and trying to avoid forcing them to do their own joins in BI tools or compute arbitrary SQL, that's a huge opportunity to kind of standardize that once and make sure that they're able to get an accurate chart of revenue versus churn, no matter where they run that query from. Okay, let's talk about opportunity number 2. So this one gets into actually using our dimensions in kind of a more powerful way. I mentioned the trend chart. So let's take a metric and let's say that we're trending it out. In this visual, I'm showing a revenue metric. With a revenue metric, you would often label descriptions. Let's say we're an e-commerce business. You might label dimensions, like color or product line or product model. And each of those dimensions is a drill down that a business user may want to do with that metric. So they may want to sort of cut revenue by product color or by product model. You can imagine the scenarios for that. Things like I want to see how our color popularity is shifted over time, or I actually want to drill down and see did the model that we introduced kind of replace the model that we sunsetted, and did we lose any revenue off of that? So this is really powerful because the fact that those dimensions are kind of pre-labeled and predefined means that the pivot query necessary to do the automatic breakout of those dimension values is, again, deterministic. Like we can script it in Jinja. It runs the same way every time. It's going to guarantee that your data consumer gets the same answer for how much of product mix of yellow versus red did they sell last quarter or last year. So there's a ton of power in that automatic drill down. And when you combine it with the filtering as well, it gets even more powerful because you can, oftentimes our questions take us into these iterative cycles, right? Where you might say, I want to see how our yellow products did last quarter. So you might filter to yellow, but then still need to drill down by model name. And so having those dimensions there and can make that super easy. All right. Our third opportunity is around how we build trust with data users. So one of the most common complaints that I typically hear from business users of data is that they log into their BI tool or they log into their data warehouse and they don't know which tables and columns to trust versus which ones might be outdated or still in development. And that can be super frustrating as a data consumer because you feel like, okay, I just have a simple question to answer, but I see 5 different tables named with some variation of sales on them. I don't know which one to use. It seems like maybe one was old and then it got updated, but that doesn't actually point me to for sure which is the right column or table to use within my analysis. And for us, this really jumped off the page as we were meeting with these data consumers and kind of building Roscoe, is the fact that a simple verification workflow that makes it easy for the user to just visually consume that verification status when they're querying the data is super critical. So what you're seeing here in the screenshot is just a very simple visualization that takes a metric, and once it's gone through an approval workflow, it'll actually show up with a verified badge. So that's the visual indicator to the data consumer that, hey, this metric is verified. It's kind of blessed for usage. If you use this revenue calculation in your dashboard or in your query, then you're not going to get yelled at later, right? You're going to get an answer that we can explain and stays consistent. So the meta kind of section of the metric YAML definition is a great place to store some of these attributes. So we store things like when the code review is in progress and the data team is kind of reviewing the SQL logic that's been created in order to build that model and that metric, then that kind of shows up as in progress within our UI for users that are looking at data. Similarly, once it's been verified, obviously you have the verified badge, and then we have a not verified state. All of those things you could include in that meta section and kind of make sure that users know what they're looking at. Okay. Next up, let's talk about kind of how these three things come together and what does it mean to your data team and your organization. So my takeaway after working with the metrics package and working with a lot of enterprise data teams as they are kind of starting to adopt semantic layers or looking to maybe refactor their semantic layer is that you get a lot of advantages from standardizing that business logic in metrics instead of in dashboards. Some of the answers or the reasons are obvious, right? Dashboards cause vendor lock-in because the SQL that you generate through a Tableau or maybe based on your LookML specs, that's proprietary to that tool. It kind of keeps you locked into that tool, and it means that if you connect to that same data from any other BI tool or even Excel or just write a query in Snowflake, you won't get the same answer because you're not querying the semantically modeled version of the data. You're querying sort of the data warehouse data. So there's a built-in advantage there, just that the logic being in dbt means that it's possible to compute it that way every time you query Snowflake. There's other advantages, though, that are actually more nuanced. So one of the things we've heard frequently from data consumers and organizations that we've worked with is they get frustrated by stranded dashboards. And data teams do as well. The frustration is not unique to the person trying to read the dashboard. So we hear things from data teams like, yeah, we have 700 dashboards that are published in our Looker instance, but we only use 25 of them at any given time. And that's really frustrating because you've gone through the work to build that dashboard. It was probably necessary at that time, right? That day that you built it. It was very important to answer some executive's question. But 3 months later, it may be in a state where it's showing inaccurate data, or the metrics on it, have changed business logic in the warehouse, but the updates are not reflected in the dashboard that you're looking at that time. So that pain point of stranded dashboards is like a massive productivity sink and kills data trust within an organization. So the advantage of defining your kind of logic in the metric layer instead of in the dashboard layer is that, number one, it's way more obvious to you when you need to review, make changes, or update it because it's all in one code repo, right? So if you find yourself having multiple metrics for revenue in one code repo, I mean, that's kind of on you, right? That's not so much on the person that built the dashboard anymore. The other opportunity there is putting it through this kind of verified workflow process. That's something that we've seen customers and companies try to set up around dashboards, but it's much more difficult to have a pull request review workflow around a dashboard than it is around a YAML file that's in a code repo. There's a great quote that kind of hits home on what we've heard from data consumers from Ben Stansel. He said in his newsletter in April 2021, he said that, I'll paraphrase a little, what the data consumer really wants, he calls it analytical Mad Libs. They want to see a metric cut by a dimension or multiple dimensions with a filter on it over some time frame. And he talks about how a vast majority of user requests really flow from just something that simple. And so that's really what, in those cases, that user's not, in my opinion, asking for a custom dashboard, built from scratch to answer that question. They really just want a basic metric definition that they can interactively query. There's always going to be cases for your operational dashboards that require, are rolled out to hundreds of people and do need to be kind of kept as living, breathing assets. But in this analytical Mad Libs world, I think it's much simpler to define that as a metric. So in conclusion, if you invest in standardizing and defining your metrics right in dbt, you can avoid stranded dashboards and a whole lot of other frustration that might come with that down the road. All right. Thank you so much for joining. Please post your questions in Slack, and Josh on our team and I'll be in there to kind of help. If you disagree and love dashboards so much and you can't bear the idea of them being ripped away, please post that as well. We'd love to have that debate. Thanks so much, and really appreciate it.
I definitely have a love-hate relationship with dashboards, but I love that presentation. Thanks so much, Patrick, for that insight and that detail. If you'd like to join the Q&A with our speaker, stay in the Coalesce Why Metrics Are channel on the DBT community Slack to submit your questions and comments. If not, the next sessions are titled Escape from Data Island, Orchestrate and Connect Your Data Stack for Smooth Sailing. And there's also going to be a talk on petabyte scale lakehouses with DBT and Apache Hoodie. Both of those will be starting at 3 p.m. Central, and we hope to see you there. Thanks so much.